Hello, welcome to another episode of Factory of the Future. I'm A.W. Schultz, along with Alexandria Burek, and we have a special guest today. In today's show, we have the CTO of Carbon, Dr. Jason Rolland. He oversees the research and development to address product needs across a wide range of different industries. But we're talking plastics today, and no further expert that I would rather talk about it was than Dr. Jason Rolland. He is the co-inventor of Carbon, a dual-cure material platform, which has led to the development of a broad range of materials, including rigid, flexible polyurethanes, elastomers, high-temperature cinnate ester and epoxy-based resins, dental resins, and silicone-based materials. Previously to his parts with Carbon, Dr. Rolland was a senior director of research and diagnostics for all, and co-founder and director of R&D at Liquidia Technologies, which is currently being traded on NASDAQ. He holds a Bachelor's of Science in Chemistry from Virginia Tech and a PhD in Chemistry from UNC Chapel Hill. A named inventor on 36 issued patents and over 50 pending patents. Dr. Rolland has also received numerous awards recognizing his achievements, including the American Chemical Society, ASC, in 2014, the Catherine C. Hatch Award for Entrepreneurship Success, and in 2019, he was named the recipient of the prestigious ACS Polymer Young Industrial Polymer Scientist Award. I got to tell you, I was looking very forward to this interview for some time, and we were finally able to get it together, and it did not let us down. In the episode, Jason goes into explaining some of the difference what goes into the mechanical and chemical recycling processes, and some of the things that we can do to try to impact what we can do for some of the environment and the plastics that are out there today. But we also go into conversations of the different applications that Carbon is currently working on and where they see themselves down in the future. So stay tuned. I hope you enjoy this episode as much as I did making it.
Welcome to Factory of the Future, People-Powered Output, podcast focused on trends shaping the future of manufacturing. I'm Alexandria Burek, your host, here with A.W. Schultz, two thought leaders with a passion for people and manufacturing. Today and every episode, we are diving deep into the advancements, sustainable practices, and dynamic changes transforming how we produce everything.
And now welcome Alexandria Burek and A.W. Schultz.
Okay, we're recording, and one of the things I want to get here, I'm with Jason. He's the main figure at Carbon, and today we're going to be talking about 3D printing. And I'm excited to talk about it because I honestly think there's a lot of benefits and what can be used into it. So one of the things I wanted to get into, and I already pressed Jason on it, was the idea of, what are some of the advancements that we see in the future in the manufacturing sector, particularly in the storeroom, and also what uses are you seeing as being popular in your organization that's currently that you're seeing down in the pipeline?
Yeah, sure. All great topics. So just to give a little bit of background at Carbon, we've been doing this for about 13 years. We were founded back in 2013 and really stuck true to the goal. The original goal was, how do you take 3D printing, aka additive manufacturing, I'll use those interchangeably. How do you take this technology and move it outside of just being a prototyping technology? I think when most people think about 3D printing, they think think about a little desktop unit that can, print a fun little toy or feature or something, and or it's useful for in a prototyping context before you go and cut your tooling to actually manufacture things. And we saw that there was a lot of untapped potential in this space to actually bring the promise of 3D printing into the world of producing end-use parts. And so that was where we started, and what the pitch that our investors bought into. And so in order to do that, we had to make a series of fundamental advancements within the technology. And I can get into as much detail with that as you can stomach. But one of the big things that we got a lot of attention for was around print speed. And one of the main limitations of why 3D printing isn't used in a manufacturer or hasn't been used in a manufacturing context is because it's too slow. And therefore the throughput of parts is too low, and the cost, and that all, throughput is directly related to the cost and all of that. And so we had a major advancement and specifically in this type of 3D printing, I'm talking about liquid resin 3D printing. There's a lot of different categories. Here we're talking about liquid resins that solidify upon exposure to light. And we are able to project patterned light in a series of slices in order to build the part. And again, I can get into more detail if that's helpful. And so we had a particular breakthrough in that category of printing that allowed us to print 10 to 100 times faster than standard 3D printers. And we got a lot of excitement. We got a lot of recognition for that. Our founder gave a talk at TED in 2015. And we printed a little lattice ball live on stage in 5 minutes. So that was really exciting. And so that was step one. And so now we had this exciting technology that could print really fast. The next big piece that we had to solve was around the materials. And this is my background. I'm a material scientist by training. And actually why I was brought onto Carbon was to build out the materials team and the materials platform. And there, again, we wanted to do something very different. Again, just to orient people, I'm talking specifically about polymeric materials or plastics, elastomers, those types of things. Not about metals or ceramics or other categories of 3D printing. I think all of that is really interesting and exciting. We are focused on polymeric materials. And so one of the big challenges we had to face there is how do you make UV curable materials perform at the level required for certain end-use products? So something like a running shoe, for example, has a lot of requirements around durability and stability, and just all, energy return, tear strength, all of these things that you care about in an end-use application, all of a sudden become very, very serious. You can't just have a prototype of something that looks like a shoe. It has to perform as a shoe. And so we had a series of materials advancements where that really opened up the space of chemistry that we could put onto the printer, and therefore opened up the range of mechanical properties that we could achieve through this system. And again, happy to get into any detail that you want on that.
Yeah, you said, I don't know a whole lot about 3D printing other than I think it's really cool. But so you said you made a resin ball within 5 minutes. What was the normal time, or how did you beat it? What would I expect to be another printer to do?
I think at the time a different printer, could have taken anywhere from 3 to 8 hours to print an object like that.
Okay.
Yeah, so in that range. Again, there's a lot of different types and a lot of caveats in that statement, but the point is that we were able to greatly improve the speed of printing.
And I'm just going to ask a very simple question, I guess.
Please do.
I was part of a society we were ranked where we did judging on these high school kids that all over the world. I can't think of the name right now, but anyway, one individual was activating or vocalizing about using recycled bottles and not turning it into like a powder or something, but the wound it and reusing it, and he said could be the usages of it, because a lot of plastics while we say it's recycled, isn't actually getting recycled.
Yeah,
So,
I could spend the rest of the time talking about that topic on recycling, but I love those types of ideas, and so that's an example of, again, we deal with liquid UV curable resins. That's one category of 3D printing. There's another category, generally referred to as FDM, or fused deposition modeling, and there you're taking a spool or a filament, so like a thin thread of what we would call a thermoplastic, so a plastic that can be melted and extruded. And you're sort of drawing your part one line at a time in multiple layers. That technology is super useful, in particular for the sort of hobbyist home use case. There's a company out of China called Bamboo that is really dominating that space right now. They have a very easy to use product that's super reliable and works really well. And they're even doing, there's these production farms in China that are just warehouses full of these small FDM printers, printing all kinds of things. So yeah, super useful. And I think if you can, find a more direct way to recycle things like, PET in a plastic water bottle, then by all means, we should do that. I think that stuff like that's really great.
well, it looked like I touched a nerve on it, and I'm kind of curious. What are your thoughts on plastics? And
Yeah.
I'm just going to let go with that. Because
Yeah,
it sounds like you know something.
Yeah, we get asked that a lot, and I'm a polymer scientist by training, so I do find myself defending plastics from time to time. But because I think certainly there are single-use plastics, things like the water bottle that you referenced that I do think have become quite a problem, and I do think there are a lot of areas where they're used where there are good alternatives that we should migrate towards. And so on things like that, I totally understand. People see these things on the news. They see ocean plastic on the news, which I find deeply concerning as well. There's a lot of concern out there about microplastics right now, and I think some of it is a bit clickbaity, but no, I do think there are some real concerns out there, but there are also high value, what I would call high value polymer based products that we all interface with every day, whether it's the components in your car, or your running shoes, or I'm going to name areas that carbon's active in, but things you might not think about. Dentures, people's dentures are made of polymeric materials, and that's a medical device that allows someone to speak clearly, that gives them their smile back, allows them to eat the foods that they want to eat. And so there are really high value. There are tons of whole categories of medical devices that are made of polymer, high medical grade polymers, plastics, things like that are life saving. And so those are the types of things that Carbon is focused on. We are not focused on making single-use plastics for packaging or things like that. So, I'm happy to chat more about that. But we, like it or not, the world is utterly dependent and run on polymeric materials. And many of those are providing value in our lives that people might not recognize.
Okay, I might ask you a question you might not have the answer to, but what are your thoughts on the movement from being oil driven? Plastics come from oil, and the reducing of gases and going to electrics. What do you think about the future of plastics? It's almost I'm going to call it a byproduct of oil or of gas, and we've just been so smart to find different uses for it. Because I spent some of my time in my industries in the polymers and in other different plastics manufacturings, and they definitely need the materials. But do you have an opinion on where you think it's going to happen? What's going to happen in the future?
It's a great topic. I'm glad you brought it up. There's basically two main sources. The vast majority of the building blocks for polymeric materials are exactly what you said. They're byproducts of oil. And the really interesting fact is it's like 5 to 10% of the total volume of crude oil provides the raw materials for almost the entire plastics industry. So it just gives you a sense of the scope of volume of oil that is processed and manufactured, and just how dependent our economy is on it. But there's another growing category of bioplastics. And these are areas, and carbon has some resins that are, have a significant portion of bio-based raw materials in them. And here, instead of getting those building blocks from petroleum, petroleum processing byproducts, you're getting them from plants. And so, we have a couple of materials that are polyurethanes, which is a subcategory of elastomers or rigid components, but they're generally known as being very tough. Spandex is the most widely known example of a polyurethane elastomer. And again, that has building blocks that traditionally come from the petroleum industry, but there's...
So spandex is made out of plants?
No. Well, actually, probably some spandex is made out of plants, but but spandex is a polyurethane. Okay. Which is a stretchy, tough elastomer. I'm just giving people a visual. When I say polyurethane elastomer, they can think about spandex. Okay. Yeah. Or when you buy like your stretch jeans that have 5 to 10% polyurethane fiber in them, that's what's giving those that sort of stretchy feel. You can make components of polyurethanes that ultimately drive back to sugars from corn. And so we have partnered with chemical companies that do this. And so you can, you instead of using petroleum, you're basically using CO2 from the air and sunlight to build a plant. And then the plant makes sugar. And then you can extract that sugar and modify it into building blocks of polyurethane precursors.
Is the process to make these resins similar to how these companies currently do it, or would it be just re-engineering everything?
It's in some way, at a certain stage, it's re-engineering everything, right? So instead of doing processing your byproducts of petroleum, you're starting at a different point. So you're starting with like sugar, and okay, now I have sugar and I need to break it down into a component that becomes the stretchy part of my polyurethane elastomer. And so it is a different process, but you end up with a building block that's very similar. So once you have that, then that fits into maybe your standard workflow for, in our case, when we go to manufacture and blend the resin formulations, at that point, it's going to be the same whether it's derived from plants or from petroleum. So at some point, they intersect, if that makes sense.
Yeah, it does. And the only reason I brought this up, because I've supported some of these facilities, and they're absolutely gigantic. Yeah. So, and I'm just wondering, like, how big of a change would it be if they had to change it, or had to change their own process? And you're saying that it would be... There'd be some significant changes.
It's significant, yeah. You're building a very different type of reactor at the end of the day to build this. Yeah. But it is a growing area, and it's growing. Consumers are wanting more sustainable materials. The bio-based plastics, just to make an important point, people hear bio-based and they immediately think compostable, and this is similar to cellulose and things like that. I do too. There are categories of that, so you can have compostable plastics, but bio-based, it doesn't always mean it's ultimately compostable. It just means that it's often a significantly lower carbon footprint to manufacture that resin than if you were doing it from petroleum. And that's because, again, you're leveraging existing CO2 in the air and sunlight rather than, expending the energy to process petroleum products.
What are some of the kind of trends or stereotypes that, Dr. Rolland comes across that that others may not be, that we might be naive to, but it's kind of common nature for you. I think about plastics. I guess. Yeah. Stay in that wheelhouse on it.
Yeah, I think it's probably what I was stating earlier is just people hear about plastics and they immediately think plastics bad, and plastics are not sustainable and they're, causing health problems. And I don't mean to make light of that, because there are serious problems there. And in particular, the one that gets me the most is the ocean plastics. It's such a disturbing image when you see these just like, gigantic areas of the ocean that are just, covered in plastic. And that's all addressable, and a lot of that ocean plastic comes from countries that don't have landfills and municipal trash, workflows. And so what people end up doing is they put all their garbage on the beach, and then the tide comes in and washes all that garbage into the ocean, and then you have a clean beach again that you can dump your garbage on. And so there are organizations that targeting that directly, but that is a lot of it comes from Southeast Asia, and that's the stuff that really gets me. And so I acknowledge that, and I certainly acknowledge that there are real serious sustainability and environmental problems. But I think people tend to they throw a general category around all of that, and maybe fail to appreciate the impact that plastic and polymeric materials have had in their lives. It's easy if you're not looking for it, it's easy to miss it. But I think it's unappreciated for a lot of people on just how much of what makes their lives convenient and in many cases positive is driven by these amazing materials that we've developed over the past 100 years or so.
I like that you brought the bio, using the plants idea, because I've been scratching my head on that. If we want to reduce fossil fuels, and you're saying there's answers to that, because I don't think we're going to walk away from the idea of the many uses of plastics, and I'm kind of an advocate for it. But when I think about the ocean, when you mention that, what would the viewers, and I'm asking, I know I'm asking an expert, what can be done about that?
About specifically around ocean plastics?
I think so. I don't want to go too big on it, but
in my opinion, this is just my opinion. I think oftentimes in conversations around sustainability and environmental issues, there's this posture of, if it isn't perfect, then it's not the right solution. Whereas I tend to think that incremental improvements and things that make progress but aren't perfect are good and are worth considering. And so, I think that brings me to the topic of landfills, which generally people hear landfills and they think, oh my God, it's horrible. We put all this garbage in the ground. And I understand that perspective, but I would sure rather have plastic waste be buried in an area where there aren't people, and ideally it's a big hole that we're digging and we're putting. I would much rather have it be in there than floating around in the ocean. And I think most people could get on board with that. And there are efforts where people are trying to implement, more traditional, or at least modern municipal trash systems that you see in the West and other parts of the world, and implement them in these countries that don't have those implemented, where you do just have, garbage just kind of going everywhere. And, so again, that's not ideal. I totally recognize that, but it's far better than having plastic end up in the ocean. I think, so that's step one. I think also, again, recognizing where can we substitute degradable cellulose-based materials for these single-use plastics. And there's a lot of progress on that being made as well. And I think that's amazing and it's great. Where can we reuse things? People have these reusable water bottles instead of plastic water bottles. I think that's all great, and so it's a multifaceted problem and therefore requires multifaceted solutions. But in my opinion, the biggest impact you could have specifically on the ocean plastic issue is to build modern municipal trash systems in these areas that there's some statistic where 80% of the ocean plastics come from, I think it's fewer than 10 rivers in Southeast Asia. And so, that starts to scream like, oh, geez, why can't we just direct that into a more reasonable location?
Yeah, to your point, people they want to do good things, but if you make it easy for them to do good things, they'll do it.
Yeah.
So if having that availability, making them just aware, and having put the trash in the discarded containers into the appropriate containers, those are kind of the opens the light on some of these problems we have.
And I we haven't talked about recycling, but I think recycling has great potential, but it is largely it's not an effective solution to this problem. It hasn't proven that the modern ways of recycling have not proven to be an effective solution to this problem that we're talking about. But that doesn't mean they can't be, and I think you could certainly imagine these closed loop recycling systems where you could start to have it, maybe it doesn't have to go to the landfill, and it can go to a different processing plant where the plastic is either broken down back into its building blocks, which is a new trend that's been happening over the past couple of decades, called chemical recycling, which I'm a big believer of. I think that is the future, and that is the only way we're going to get to a true closed loop, highly effective recycling process.
Can you elaborate a little on that? I'm interested in that.
Yeah, so there's two different categories. One is chemical recycling, which I just described, and another is mechanical recycling. What people often think about, and what is by far the norm in mechanical recycling, is where you take up that plastic water bottle and you chop it up into flakes, and you might clean it and process it a bit, and then it goes to a molding facility where it is molded into a new form. The issue with that is you lose property, you lose mechanical properties when you remelt that plastic. And so you can only do that maybe once. And even when you do recycle it, it tends to be, you'll see water bottles, Coca-Cola is big on this one, say 10% recycled content. And the reason why it's only 10% is because if they use more than that, then the bottle won't do what the bottle needs to do, which is, I need to break it, or I need to be able to drop it and have it not break, and things like that. So it's ultimately limited. Again, I'm not trying to take away from the effort there. I think it's great, and we should do more of that where we can. But as you said, if you look at the stats, it's about 6% of plastic of plastic that can be recycled, that gets into the recycling bin, is actually recycled. And it's usually what people will call downcycling, where because of that loss in properties, you have to take a step down into the level of products that you're doing. So that's a big problem, right? So that's not a true recycling process. What is emerging now is this chemical recycling. And again, a lot of the major chemical companies are jumping on this, and Europe is a bit ahead of the US, although the US has some of this going as well, where in chemical recycling, so polymer chains, plastics are composed of polymer chains. Polymer chains are just long chains of molecules, and they have building blocks. And they're often, the same building block, or sometimes there are a couple different building blocks that alternate. But this is back to the source of those building blocks is ultimately petroleum and plants. With chemical recycling, you're taking that bottle that is already molded and has, very long polymer chains, and you are breaking down the chain back into its building blocks. And then you can purify those building blocks. They're called monomers. You have monomers and polymers. Yeah. You break those back down to the monomers, and then you can purify that. And now you have, when you repolymerize those monomers, you're back to making a very high molecular weight or high chain length, and you don't lose those mechanical properties. It also makes it far easier to deal with mixed plastics. And far easier to deal with contaminated plastics, because you're, going through these processes on smaller molecules and then using those as building blocks again. So what I hope becomes the norm is that we have more and more facilities that are doing chemical recycling, and I think that gets you into a much higher yield and more cyclical process that can do this. But it's going to take effort. It's going to take commitment from governments. It's a whole ecosystem that you have to build in order to do this successfully. And again, I think I see a lot of effort on this, in particular in Europe. That's pretty exciting.
Yeah, I think that the work that Carbon is doing and you're part of is it's exciting. And you talked about coke and recycling. The same is true for the aluminum. When they form it too, the actual top, the lids on the cans, that they can't use that into the same molding of it. It has to, I guess, is a level of zinc on there that has to be part of it. But it's a similar thing. They can't. I can't.
Yeah, aluminum and cardboard actually and glass all have very high recycling rates. They're much, much better than in the world of plastics.
Oh yeah, yeah.
Yeah, and again, I think it's a processing point, and it's a similar thing where you don't, with aluminum, for example, you don't lose properties when you melt aluminum down and recast it and remold it, and it's also easier to purify that in the molten state than things like polymers. So I'm a big fan of chemical recycling, and I'm excited to see that take off a bit more.
Well, yeah, I talk about like circular manufacturing, and I hope that's the future, because the more we can use things and recycle them, and that it's a better place.
And you get into other, there's a lot of sustainable topics that overlap with the world of additive manufacturing. One of them is what you mentioned, this sort of storeroom or cloud-based inventory is the name in our world for it, where instead of having giant warehouses that are climate controlled and filled with a huge inventory of components and plastic parts, you have instead this like cloud-based inventory, a digital inventory of your parts that's much easier to maintain, and you're printing as needed, and you're not trying to play these supply chain games of predicting what will I need for the next 6 to 12 months. Instead, you have a much shorter window that you have to worry about. And that has all kinds of implications, from a carbon footprint story, from a localized production story, as supply chains get more and more complicated with geopolitics and tariffs and all these things that we've seen happen. All of that really, our supply chain struggles to keep up with those changes because it's not adaptable, or at least it's slow to adapt. Whereas if you have flexible, localized factories that are using additive manufacturing with, and they aren't locked into a particular type of part, and all of that is digital, that's a very different situation. And that's something that is much more adaptable to rapid change and, changing needs of what their customers are requiring.
I was, this idea, and why I was so excited to have you on, I was in Africa at an energy plant, and I'm doing a training on planning and scheduling, because that's kind of where my background goes into. Yeah. And in the U.S., you can kind of get everything you want really quick, but like I was in Ghana, and we were talking about lowering the costs and inventory, lowering your cycle costs, and I'm going over that. And I remember them saying, like, AW, when we order something, it takes months to get it. So, and they had a great storeroom, by the way, but it's just, they have to keep so much inventory. Exactly. And that's kind of where I joke with it, because I just think that, man, they definitely need like additive manufacturing. That's a good use case too of, resource challenged settings where, it would be great to make what you need. And that gets into, defense demands within additive manufacturing, and there's a lot of things that open up around that. But
But yeah, so just tying this all back to carbon, we do have, we think a lot about sustainability. We have made a number of advancements. I mentioned the bio-derived resins. We have made huge advances in reducing the amount of waste generated in additive manufacturing, in particular, like I said, in our version of it with liquid resins. We have developed solvent-free cleaning processes that are widely used in the production of products made with our technology. And so it really is starting to open up new product categories that are all enabled by this additive manufacturing technology. So, we have products in footwear. We've had a long-standing partnership with Additive for going on about 10 years right now. And they are moving into some really exciting products. You can look this up on the website, but there's a new shoe called the Climacool shoe, and it's a fully 3D printed sneaker. And that's very, very cool. What's interesting about that is if you think about a standard sneaker, it has a dozen or two, one or two dozen different components on it. And all of that needs to be sourced. All of that is coming in on cargo ships and whatever. And then it all needs to be processed and assembled. And that takes a lot of labor. It takes a lot of energy. And now you're entering into a world where the entire shoe is 3D printed. And that's more or less the end of the story. And then that product is shipped off and goes to the consumer. That's a very, very different supply chain than what you would think of from a standard footwear supply chain. And so you have this really interesting intersection of products that can't be made any other way that are also providing, benefits to the consumer. We haven't talked about football helmets, but I'd love to talk about that. And all being done on manufacturing technology that is adaptable and in many cases more sustainable than traditional methods. So that's what's so exciting about this space right now, is that it's really starting to touch base with consumers, and they might not even realize that the part that the football helmet they just bought for their kid has 3D printed pads on the inside of it that are the highest performing cushioning systems that have ever existed. And that's ultimately our goal, is to get people to not even realize that they're using a 3D printed part. They're just using it because it's better. They're using it because it's a better bike saddle or a better football helmet or a better sneaker. And that's starting to happen, which is really exciting.
Okay, yeah. And so if you want to find out more about, is it carbon3d.com?
Yeah, Carbon, name of the company is Carbon. Website is carbon3d.com.
Yeah.
And there's a ton of information there about our technology and a lot of use cases and brands that we work with and success stories. So it's very, very cool.
Anything else you'd like our viewers to know about what you've got going on or Carbon's got going on that might be of interest?
Yeah, mainly for this audience, just want people to be aware that these capabilities exist, and that if they have ideas and needs for products to come and chat with us and see if our technology would be a good fit. I would say in particular, people who are dealing with foams, we have this category of products that we call elastomeric lattices. So they're just lattice structures that are soft and squishy. And we're finding a ton of benefit versus foam products, and finding replacing foam products with these elastomer lattices provides a better end product for the consumer. So something like a football helmet, it's more breathable, it takes much higher impacts and dissipates energy much better, and it's just an all-around better experience. So just be aware and let us know if you have any product ideas.
Yeah, it's such an exciting space that you're working in, and I encourage people to go to carbon3d.com and learn more about it. But this is Factory of the Future, and Jason, thanks for coming on.
Really thanks a lot, AW. Appreciate it.
All right. Okay, and I'm going to stop recording. This is Factory of the Future, and we are out of here like finished goods. Stay tuned for our next episode of Factory of the Future, where we're exploring groundbreaking techniques and behaviors that are reshaping industrial landscapes.
Don't forget to subscribe and leave us a review and help others discover the cutting-edge insights transforming manufacturing as we know it.